Just kidding. It's not the real ocean, it's Mr. Cruz's desk. I wanted to give you guys some real world examples of symmetry that we can look at, but it's kind of difficult to bring wild animals into my home. So instead, I've got a few things that I picked up from my niece's room, who happens to love ocean animals. And so that makes it very convenient for me to pull resources from around the house. This one is a little ceramic model of a shark. And as we can see here, it exhibits bilateral symmetry, just like we discussed. If you draw a line down the center of this shark, you'll see that on one side, on the left, it looks exactly the same as on the right. Everything is equally shaped. That's only one form of symmetry, though, right? We also have bloop, 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 radial symmetry. So remember how I said that jellyfish exhibit radial symmetry? If I hold this straight up, you'll see that this is a pretty good example because it's a circle. So if we have a spot in the center here, I'll try to get it right there. If we have a spot in the center, you'll notice that every point on the edge of a circle is equidistant from every other point on an edge. You could draw a line from the top of this jellyfish to the side of it, and you would always have a line that is the same length, no matter which direction you decide to go from the center. But we also, if we look at the underside of it, you'll have to excuse my dogs. If you look at the underside of it, you'll notice that we have these tentacles that come off as well, tentacles that come off as well, and those are also equidistant from the center, thus meaning that we have radial symmetry. These tentacles radiate out from the center of the jellyfish. Now, there are some that can be kind of tricky. Like take, for example, this bivalve shell. It looks like it would be an asymmetrical shape because when I draw a line down the center, I've got something different on this side than I do on this side. But wait, if we were to turn it and look at it from this angle, we would see that we have equal shapes on the left and right side. So even though this axis does not provide symmetry, we have a different axis of symmetry right here. You have to keep that in mind when you're looking at these animals. Sometimes it helps to have a 3D image of them. Now, I wanted to show a sea sponge because they happen to have an amorphous shape that exhibits asymmetry. But that's a little bit of a challenge because I don't have any sponges that aren't square and made of plastic. So I am going to simulate that with a sheet of paper. Imagine, if you will, that this is a sea sponge. Notice how there's no line that I can draw where it's equal on the left and right side. And not only that, if I start at the center point here, then let me actually grab this so it's a little bit easier to see. If I start at the center point here, I can draw a line this way, and it's a different distance than if I drew it this way. That would be from here to here is a longer distance than from here to here, or here to here, or here to here. So I don't have radial or bilateral symmetry. But that's not the only way that something can be asymmetrical. We also have this wonderful gastropod shell. This is from a sea snail that my niece picked up in the off the coast of Jekyll Island. And if we look at this, we've got a spiral. A spiral is always going to be asymmetrical. If you draw a point right here and then you drew a line out to this part of the shell, it would be a different distance than if you drew it to this part of the shell. But not only that, the pattern of these layers of the spiral would be different.